So question number 10. Diagram shows a combination of triangle ACB, BCD and DCA. Given that angle ACB and angle BCD are obtuse angles, which means that the angle is more than 180 degrees. So it is given that DB is equals to 8, BC is equals to C, AC is equals to 10, and BDC is equals to 40. So if the area of triangle ABC is 22 cm, we can calculate. So the first question A, they want us to find the angle of ACB, which is this angle right here. So as we know, this is the formula of area, and we're going to use the formula because they stated that the area of this triangle is 22 cm. So the area is 1 over 2 BC times sine A. So this is our B, this is our C, and this is the angle that we're going to find, which is angle ACB is actually angle C. So we just plug in the values, 1 over 2b, which is 6, and 10 for C, and sine C. So inverse sine C, we will get 47.1666. Since it is an obtuse angle, as they stated in the question, it is more than 180 degrees, and this one is clearly not, is less than 180, so we have to find the corresponding angle. So 180 minus 47.166, and we will get the final answer, which is 132.8334 degree. So moving on to the next question, they want us to find the length of BA. So this is the length that they want us to find. So let's write up the previous answer, 132.83 degree. So right here we have we can use cosine rule. This is because we have two sides and one angle. So A squared equals to B squared plus C squared minus 2BC times cos A. So the A is what we want to find. This is our A. Since this is angle A, this is angle A, this is our B, and this is our C value. So we're going to plug in the value. A squared is what we want to find, and 6 squared plus 10 squared minus 2 6 sine tens times cos 132.82, which is our A right here. So we will get the final answer, which is 14.75. So moving on to the next question, they want us to find the angle of DBA, which is this angle. So we can find this using two separate triangles right here, and this triangle, and we will I will rewrite the answer for the previous 132.83. So from here we know that the total angle is 180 degrees. So we can find this angle to find this one. So we will use sine rule, which is sine x, and this is the new x that we're going to find. Let's make it clearer. X here, sine x, and the opposite is 8, is equals to sine 40 divided by 6. So the angle of BCD we will get 58.987. And since this is an obtuse angle, which is more than 180 degrees, we have to find the corresponding angle, and using 180 minus the angle that we found. So we will get the final answer is 121.013. So this is 121. Here we get 121.013. So after we have two angles in the triangle, we can find this angle using the total angle of triangle, So 180 minus 1 to 1.013 minus 40, and we will get 18.99. So 18.99 is here. Okay, so we can find this another one to complete the angle that we want to find. So using Sine Rule, we use sine B. This is our B that we're going to find. So the corresponding side is 10, is equal to sine 132.8, and the corresponding side is 14.75, and we will get that the angle is 29.82. So we can complete this to find this angle by adding these two values that we get, which is 29.82 plus 18.99, and we will get 48.81. So the last question is question D. They want the area of a triangle ABD. Triangle ABD is this triangle. So we can directly use the area formula because we have the side for both, and we have an angle for here that we found just now, which is 48.81. So 1 over 2 times 8, which is B, and 14.75, which is the C side, and times sine A, which is the answer that we get from question C, and we will get the final answer, which is 44.4. That's all from me. Thank you.